if indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who have been programming for years might not necessarily be in the best habit of indenting your code properly. And one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Yeah. Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here. And indeed, it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks instead. It relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts. And that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose here that we explore this kind of logic by way of another program altogether in VS Code, whereby I'll go ahead now and create a new program, say, called grade.py. Let's consider exactly what grade a student should get based on their score on an exam or a test or a quiz or some other assignment like that. I'm going to go ahead and run code of grade.py to give myself a new file. And I'm going to go ahead and start by just getting the user's score, again, on some assignment or test or the like. And I'm going to store it in a variable called score equal the return value of the int function, which is going to convert whatever the user's input is when prompted for this score. So again, the user should just oblige by giving me a number like 0 or 1 or 2, or hopefully much higher than that, like 97, 98, 99, 100, assuming the test or assessment is out of 100 percentage points. Now, how can I go about assigning a grade to the student's score? Well, in the US, it's very commonly the case that if you get between a 90 and 100, that's an A. And if it's between an 80 and an 89, it's a B. If it's 70 and 79, it's a C, and so forth, all the way down to F, which should be E, but we'll see that there's a bit of a jump. So how might I express this? Well, I can use conditionals, and I can ask a few questions and then print out the student's grade accordingly. So let me express it like this. If the student's score is greater than or equal to 90, and the student's score is less than or equal to 100, so it's in that range, let's go ahead and print out that their grade shall be an A, because they're in the 90s above grades range. If the score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways. And maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the student a B if it's in the 80s. If score is greater than or equal to 70 and the score is less than 80, I'm going to go ahead and give them a C. If the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade. So that's the catch-all. And I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D. Else, it's going to assume that you got an F. Well, let's try just a few of these here. Let's run Python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time. Maybe it's a 95. Still an A. Starting to slip further, so I got an 89 the next time. That's now, say, a B. And let's say I really had a bad week and it's now like a 71. That's now a C. Or I didn't even submit it at all. That's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong. It's correct. And indeed, according to my own specifications, I dare say this code is correct. But can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90. But I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score, and here 70 is less than or equal to score, and then lastly 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score, and is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can in code in Python do this, which is just a little cleaner, right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further. And just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like, if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong, or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions. But again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditionals, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I'd kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary. But yes, there's absolutely other ways to do it. But I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. in mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too, to just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before, this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0 because it divides cleanly. 4 divided by 3 has a remainder of 1 because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x, question mark. And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear, a number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
Perfect.
all
And we
that.
could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote unquote even and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer. So I'm going to go ahead and print out quote unquote odd instead. And let's go ahead and now run Python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd. And so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program. And I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark. And then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven. And I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote unquote even. So if this magical function called isEven returns true, even. A function that determines if a number is even, I'm just going to assume that there's a function called isEven. And I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote unquote even. So if this magical function called isEven returns true as its return value, I am going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist. And this program would break if I ran it right now. But that's OK. I have the ability, recall, to invent my own function. So let me define with def a function called isEven. I want this function to take an argument. And I'm going to call it n, just a number, generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n %2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n %2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, if it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and isEven, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more, what's x? How about 3? And it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this question for me, that I can now use in this program and, heck, maybe future programs that I write, I now have a function that no one gave me. I gave myself that I can use and reuse. And I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using a conditional up there, and my Boolean expression, something that's true or false, is going to be not something explicit like x less than y or y greater than x or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's OK because I know, because I wrote it, that that function isEven returns true or it returns false. And that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now on how I've implemented isEven using this bool.
Hello, hi David. First of all, thank you for this wonderful class day before yesterday and today itself. I have just one query, like based on my background of Java. There, when we used to pass the arguments, we can also pass the address of the variables. So is there any sort of this concept in Python?
Short answer, no. Those who are unfamiliar with Java or other languages, or C or C++, there's generally ways to pass values in different mechanisms that allow you or disallow you to change them. In Python, no. Everything we're going to see is actually, in fact, an object, but more on that down the line. How about time for one more question here on these bools and these isEvens?
So I actually had a question about defining a function,
OK.
if that's OK.
Sure.
So if you define one, are you, like within your code, like you made it up, are you allowed to use the dot operator like we did name.strip and use it like that?
Good question. If you've created your own function, can you use other functions like .strip or .title or .capitalize that we've seen in the past? You can use those on strings. Those functions come with strings. You can't necessarily use them on your own functions unless your function returns a string. for the examples you gave. I'm returning a bool. Bools have no notion of white space to the left or the right. You can't call strip. You can't call capitalize. But if you were writing a different function that returns a string, absolutely, you could use those functions as well. Well, let me turn our attention, if I may, back to this example here and consider, as we now frequently do, can we improve on the design of this code? Can I make this particular program better? And I can. There's a couple of ways here, and I'll show you something that's now generally known as something Pythonic. There's actually this term of art in the Python world where something is Pythonic if it's just the way you do things in Python. Which is to say, we've seen already there's so many different ways to solve certain problems. And in the Python community of programmers, there tend to be some ways that are smiled upon more than others. And they tend to relate to features that maybe only Python has, but not other languages. And here's some syntax that you might not have seen in languages like Java or C or C++ if you've programmed before. And if you've never programmed before, this too is going to be new. Instead of asking a question like this, if else, using 4 lines, in Python, you can actually collapse this into just one more elegant line, if you will. Instead of asking if n divided by 2 has a remainder of 0, return true, else return false, let me delete all of that and just say this. Return true if n divided by 2 has a remainder of 0, else return false. Now, those of you who do have prior programming experience might actually think this is kind of cool. You can condense from 4 lines into 1 line that very same thought. And one of the reasons why Python is popular is that it does tend to read rather like English. It's not quite as user-friendly as most English or most human languages, but notice now the line does rather say what you mean. Return true if n divided by 2 has a remainder of 0, else false. I mean, that's pretty darn close to something you might say logically in English, be it about even and odd or really anything else. So that program is going to work exactly the same. Python of parity.py, let me type in 2, it's still even. Let me type in 3, it's still odd. But I can refine this even further. And again, consistent with this idea of not just writing correct code, but writing better and better code, but still keeping it readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0, true or false? Value readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0? Or not. Like, that is by definition a Boolean expression. It has a yes/no answer, a true/false answer. Well, if your Boolean expression itself has a true or false answer, why are you asking a question in the first place? Why ask if? Why say else? Just return the value of your own Boolean expression. And perhaps the tightest version, the most succinct and still readable version of this code would be to delete this whole line, Pythonic though it is, and just return n modulo 2 equals 0. If it helps, let me add parentheses temporarily, because what's going to happen in parentheses will happen first. N divided by 2 either does or does not have a remainder of 0. If it does, the answer is true. If it doesn't, the answer is false. So just return the question, if you will. You don't need to wrap it explicitly with an if and an else. And in fact, because of order of operations, you don't even need the parentheses. So now this is perhaps the most elegant way to implement this same idea. Now, which is better? This is pretty darn good. And it's hard to take fault with this because it's so very succinct. But it's perfectly OK and just as correct to have an if and then an else, even though it might be 4 total lines, if that helps you think about your code more clearly and it helps other people reason about it as well. So it turns out there's another syntax that you can use to implement the same idea of a conditional, whereby you do something optionally based on the answer to some Boolean expression. And the keyword that you can now use in recent versions of Python is called this, match. Match is a mechanism that, if you've programmed before, is similar in spirit to something called switch in other languages. For instance, let me go ahead here and close out parity.py, and let me go ahead and create a new file called house.py. And in house.py, I think what we're going to do is try to implement a program that prompts the user for their name and then just outputs what house they're known to be in the world of Harry Potter. So for instance, let me go ahead and do this. Let me give myself a variable called name, set it equal to the return value of the input function, and I'll say something like, what's your name, question mark. And then after that, I'm just going to use a traditional if else construct to decide what house this person is in. So let me say if name equals, say Harry, as in Harry Potter. Well, let's go ahead and print out Harry's house, which is Gryffindor in the world of Harry Potter. If the name is instead Hermione, then go ahead and print out also, quote unquote, Gryffindor, as she's in the same house too. If name equals Ron, let's go ahead and similarly print out Gryffindor, quote unquote. And let's make this a little more interesting now. If name equals, quote unquote, how about Draco Malfoy in the books? Let's go ahead and print out, quote unquote, Slytherin. And just in case someone else's name gets inputted for now, let's just suppose that we don't recognize them and say, by default, else print out, quote unquote, who? Question mark, just to convey that we don't actually have a hard-coded response to that particular name. Let me go ahead now and run this as Python of house.py, enter, and I'll go ahead and type in something like Harry. And voila, we see that Harry is indeed in Gryffindor. Let's run it one more time, Python of house.py. Let's type in Draco this time, Slytherin, and now let's type in an unrecognized name. Let's go ahead and rerun Python of house.py, and let's go ahead and type in Padma, enter. And who? Because we haven't actually hard-coded with an elif condition in this case, what house Padma is meant to be in. All right, well, it turns out there's other ways to implement this. Indeed, there's some redundancy here in that we're checking if Harry or Hermione or Ron are all in Gryffindor. I feel like we can at least tighten this code up a little bit using techniques we've seen already. So let me go ahead and do this. Let me go up here and instead do something like this. Let's get rid of these two blocks of elifs, leaving just Harry's for a moment. And let's use that or keyword again and say or name equals, quote unquote, Hermione, or name equals, quote unquote, Ron, thereby consolidating all three cases, if you will, into just one if statement. Then we still have a separate elif for Draco because he's not, in fact, in Gryffindor, and then the final else to catch anyone else. All right, let me go ahead now and run this version of the program, Python of house.py. I'll type in Hermione this time. She, too, is still in Gryffindor. Let me try it with Ron. And that, too, still seems to be correct. Well, it turns out there's another approach altogether that can perhaps make your code a little less verbose. You could imagine how complicated this code might get if we had not just Harry and Hermione and Ron, but a whole bunch of other names as well for Gryffindor, for Slytherin, and for all of the other Hogwarts houses. So you could imagine that code just getting pretty unwieldy pretty fast. Well, it turns out another technique you can use is indeed this keyword called match, which is very similar in spirit, but the syntax is different and allows you to express the same ideas a little more compactly. So let me go back to house.py and let me propose that I get rid of my current if, elif, else approach and instead do this. Literally use the keyword match and type the name of the variable or value that we want to match on. And then I'm going to go ahead and include a colon. And then underneath that, I'm going to include literally a keyword called case. And the first case I want to consider is going to be Harry. And I'm going to put Harry in quotes because it's a string or a stir. And I'm going to have another colon at the end of this line. And indented under that one, I'm going to go ahead and, for now, print out Gryffindor, which, of course, is Harry's house. Otherwise, I'm going to have another case for, quote unquote, Hermione. And similarly, I'm going to have under that indented, print, quote unquote, Gryffindor, close quote. Now I'm going to have another case for Ron, also in quotes with a colon. Now print, quote unquote, Gryffindor. And now I'm going to have a other case for, let's say, Draco. This one gets a little more interesting because Draco, of course, now is in Slytherin. And then I'm going to go ahead and leave it as that for now. So let me go ahead and save this file and go back down to my terminal window running Python of house.py, enter. And let's go ahead and try Harry. And he seems still to be in Gryffindor. Let's run it again for Hermione, enter. Gryffindor. Let's skip ahead to Draco and type in Draco's name. He's indeed in Slytherin. Now let's try another name that we haven't handled a case for, like Padma again. Enter. and were just ignored. There's no output whatsoever because there wasn't a case for Padma. Now, we could, of course, go back in and explicitly add one for Padma, but what if we, similarly to the else construct, just want kind of a catch-all that handles anyone whose name is not explicitly specified? Well, it turns out the syntax for that, using this new match statement, is to still have another case, but then to use this single underscore character, which is used in other contexts in Python. But for here, it's meant to say whatever case has not yet been handled, go ahead and print out, as we did before, for instance, quote unquote, who, with a question mark at the end. Now let's go ahead and rerun this. Python of house.py. I'll type Padma's name again, and this time I think we're at least going to get an explicit response indicating who, whereas previously we did not have the equivalent of that. Now, I think we've regressed a little bit. We went from tightening things up by putting Harry and Hermione and Ron all on the same line in the same if statement. But here we have now 3 case statements again for all 3 of those. Well, we can tighten this code up as well. But the syntax is going to be a little bit different. I'm going to go ahead and delete these 2 middle cases for Hermione and Ron. And then up here next to Harry's name, before the colon, I'm going to go ahead and use a single vertical bar and then a quote unquote Hermione. Then another single bar and do quote unquote Ron. And this is how, using this relatively new match statement, you can say the equivalent of Harry or Hermione or Ron, but more concisely than you could using an if statement alone as we implemented it previously. So now one final run of the program with Python of house.py. Let's make sure that Harry's still in Gryffindor. Let's make sure that Hermione's still in Gryffindor. Let's make sure that Ron is still in Gryffindor. And indeed, all 3 of them are. Now, as always with Python and programming more generally, there's going to be different ways you can solve these problems. This is just another tool in your toolkit. Arguably, it has tightened things up. Arguably, it's perhaps a little more readable because there's a little less syntax going on, a little less duplication of equal signs and elif and elif and elif all over the place. But ultimately, this would be an equally correct approach to that same problem. But it turns out with the match statement, you can do even more powerful forms of matching as well. Here, we've used it simply to implement the same idea as that if, elif, else construct. And it's worth noting, if you've programmed in some other language, the syntax here is indeed correct. You do not need, for instance, a break statement, as has been peppered throughout, and you don't need something like default or something explicit. You indeed just use this underscore as your catch-all at the end of the match. So just by adding in some of these new keywords here, like if and elif and else, we have now the ability to ask questions about values. We have the ability to analyze input from users and ultimately make decisions about it. And these then were our conditionals. Lying ahead is going to be the ability for us to not only use functions and variables and also these conditionals, but also next loops, the ability to do something now again and again.